Hello everyone, can you hear me clearly? Great. So, so yesterday we were talking about joins. We finished up to the joins, limit including sample, and we talked about these things. Okay. So do you have any questions for me on this? All right. So do you have any questions for me? So Anand, is my voice clear now, or is everybody having this voice slow issue? All right. So no questions as of now. Should we proceed further? All right. All right. So, and are the things clear so far? Are you, are you able to appreciate the value of pig and piglet in? Okay. Okay. Now, and this part was clear to you, right? Why does dump, if we say dump twice, why does it return different samples? Because both dump sum both will invoke sample command twice, and both will invoke load command also twice. All right. Okay, let me just turn off the, if somebody bothers me here. All right, so now the next step is parallel, as we talked yesterday, that the parallel keyword lets you make a number of reducers that many. Okay, if you put parallel 10 there, it will create 10 reducers, and without parallel it allocates. If you do not have a parallel defined, what will it do? The default behavior would be whatever is the input size, it will divide by, it will count how many GB data it is, and based on that, if it is n GB, it will create n number of reducer, but it will not create more than 1,000 reducers. Okay, so my question to you is it a good approach? In your opinion, is it a good approach, or can a person do better? What are the flaws in this? Deciding number of reducers based on the data being fed to the mapper, is is this approach sounds fishy to you? Are you okay with it? What is wrong in leaving it always to pig to decide? What are the cases do you think in which pig will fail. I mean, these number of reducers is not a good idea. Can you give me a good example? Yes, as we have seen already, if we give more reducers, then data transaction will be more time. In some cases, yes. So my question is that out of all the examples we have taken so far, do you think is there is an example for which if let's say you are churning around 10 gigabytes data and it will be creating 10 reducers by default, which problem out of all the problems we have done in which we don't need 10 reducers? So if there is a 10 gigabytes of data, it'll create 10 reducers, okay? And perfect, perfect. So that's a very good point, Anand. So even if that's a very good point. Thank you. All right. So if we have some query, something like limit 10 or sample 10, we don't really require that many reducers. Yes. Or if the sorting is not necessary, it will anyway not create the reducers. Okay. Pig will figure that out. If you are not using anything like group or anything like order by, it will not have the reducer anyway. Yeah. So Anand's answer is correct. In case there is a limit somewhere, limit 10 or limit 5, that will unnecessarily trigger so many reducers. Why? While we just need one. Or another example could be our frequency count example. Okay, in which we are just getting these 26 numbers from maybe hundreds of computers, and out of these 26 numbers we just have to compute further, we just have to find out next 26 correct counts. That's all. That's fairly straightforward. All right. So okay, again I think we talked about this we talked about. All right, so let's talk about something called flatten. So the way group by created groups, so when we say group by this word and it creates the these groups, if you say flatten, it will do the opposite. Okay, it will do the opposite of group by. Okay, now you can see that here for there is Sandeep, there is C Sandeep, and so it has basically ungrouped the things. Okay, and the syntax is you load the data, that is okay. For each x, generate name comma flatten languages. Okay, this will flatten. It's basically a function which flattens the uh, records. All right, it flattens the records. It ungroups. Now there would be many cases where the inbuilt libraries of pig will not suffice, and that will be the point where you would like to call external functions. Okay, so for example, define hex and invoke for a string. There is so we want to call this particular function. This particular function is a part of Java library. We want to call that. Okay, so we can basically define our own function here in the pig. We can say define this, and afterwards we can say load this particular table as this particular file as this, and here if you look at it closely, we are using hex as if it's our inbuilt function. All right, we are using hex as if it is our inbuilt function. All right, now next is say you have your own file. You can also invoke the same way, exactly the same way which the way we have invoked Java built-in type. Just that you will have to put your own jar name at the top. You'll have to say register my jar, and then you do. And also you can again, this definition was good when we had a static function. This is a static function. For this you don't need to create a class, but if you have to create a class, then you will have to define something like this. Okay, next is, in case you have a Python library and you want to call your function, the Python library is called using a layer called Jython. Okay, which is Java Python. Jython is a library which makes you call Python functions via Java. Okay, so this way you first register your Python program using Jython and you give it a name, and afterwards you can call all those functions using this syntax where bball represents the whole file and production represents one of the functions defined in that file. All right. Next is that how to create your own functions. Let's have a look at it. The project is available here. You can take a look at the project URL, and after you download it, it's a full-fledged project which we are going to share here also. It's actually very straightforward, and say for example, this is our class. It contains a function like this. So please note that we want to create a function called upper, which so for each function you want to create, you will have to create a class that extends eval function, and under that you define a function called exec, which takes input as tuple and gives out output as string. Okay, it gives out output as string, and once you have done that, you basically compile it, and you know here there is an export function, and create a jar file. So we can give it a name here. Well, let's say we are saying pig udf, and that's all. So it has created our file in my download folder wherever I left downloads and pig udf. Okay. Now this is what it has been created. Now let's copy it. We are now copying using SCP. You might like to copy it using WinSCP. And right, I would like to copy it into my own folder. Okay. Please note the syntax. I'm saying SCP and then file name, and then I'm saying the username, add, add symbol, and then Hadoop nobigdata.com colon my folder in which I want to copy this file. Alright, it's actually fairly slow. Anyway, let's assume for time being that it has been copied. Alright, now here we already have, I think, a big folder. Okay, that has been, it's taking fair amount of time. I'm just trying to find out if I have already copied it somewhere. So it's there in the this folder also. So you can go to data. So it's there in pigudf is already there, which I had copied last time. Now we can say pig and then say register pigudf. Next is that we go to our ascii folder, and we have a data folder here. Okay, so there would be something called xyza. Where is xyza? Let's have a look at what is there. So it has some text. Okay, and let's load this text as such. And once we have I think already registered our UDF. Okay, we have already registered the UDF. All right, now the next step is we call our function. If you see, we are just calling our function out of this, and this should basically convert it to uppercase. It should just convert it into uppercase. All right, now if you look at it closely, we have called this function using our own function name. Okay, so you can see that my UDFs is the package name. That's why we are calling it like my UDF.upper, and we are basically now we are expecting that, as you can see in the code, what does code does? Code has an exec function, and inside it we have I've written this piece of code. It says that if input is null, return null, input size is 0, return 0. Otherwise, do this. Okay, what does it do in this? If if there's something in the input, further it checks. It basically converts it into a string and then converts it into uppercase. All right? It converts it into uppercase, and that's all. Now you can see as a result, whatever input we had in small, it became capital, right? It became capital. If you see, the input is small. Yeah. Sounds good? Okay. So we were able to successfully define our own function. In case there is some function which is not correctly implemented in pig, or you want to add some more business logic to something, you can create the full-fledged library using pig, using a similar kind of strategy as we have done here. All right. So my next question is, so is it clear to you? Is all of this clear to you? So it's only clear to Anand actually. All right. Now moving on. Now, there are times when there is a legacy code and you have to deal with it. So, the way we had MapReduce, where in there was MapReduce, where there was a streaming library which let you use any of your existing legacy code with Hadoop. In the same manner, Pig also lets you, in exact the same manner, Pig also lets you do all the things using the legacy code. All right, it lets you do using the legacy code. Now, for example, if you see this, all right. Now, let's say you have highdiv.pl. There is a Perl file which contains your business logic, and you want to run your data through this one. Okay, so this High highdiv.pl takes the data in the following format: exchange, symbol, and date and dividend as the standard input, and gives out some standard output. Okay, so you can write things like stream my data, whatever data it is, through highdiv.pl. Note the backcodes here. These are backcodes, and the codes which are just next to your uh, just above the tab key, and sometimes it's on the numeric 1, or sometimes just before numeric 1. These are back codes. So the reason why it has kept the back codes, because this way we can specify the command line arguments like this with double quote or single quote. Okay, with your command. So this way, this highdiv.pl is a Perl program, Perl script, which will be executed for each of the tuple in the divs, and whatever this output is given by highdiv.pl will be gathered in highdiv's new data set which we have created, or in terms of relational algebra, everything is a new relation. Okay, Now, there in most of the cases, this legacy code may not exist on all the nodes you are having in your cluster, right? In those cases, first you need to ship it. You need to ship it. So you define a function like this and say that hd means this, and then we say that ship this command, ship this xyz.pl onto all the nodes. All right. So, Jo- so Johnny's question is, what is in this legacy code? Legacy code might have any of your business specific logic, which you want to run on top of the data you have gathered in HDFS, right? It could be something like some algorithm which computes some dividend values out of it. It could be anything. So the one naive attempt would be, let's just port it onto Java, or let's just port it onto some other language. But most of the legacy code is a very, very difficult exercise to convert from one form to another. So the general strategy is, whatever it is, let it be. Let's get let's get our let's get it executed onto this new platform. All right. Now, here we just defined some command line argument for this Perl, the same Perl script which we are talking about, and also said ship this, meaning copy this and make it available on all the nodes in the cluster, just like we did at the time of streaming. We created our own sh file and we told Hadoop streaming that can you make it available on all the nodes. In the similar way, Pig also provides you the complete control of what you do. Okay, and that's why they call that pig is a very domestic animal. I mean, the basic philosophy of pig and pig Latin has been it's a one of the pillars. Okay, so okay, Santana's question is, the pig udf.jar that we did earlier is not copied to all the nodes. Um, so that one will be copied to all the nodes. Okay, that one will be copied. Just like hadoop.jar, if you remember our .jar file, and in the similar fashion, that will be copied to all the nodes. The moment you say register and then we launch it, it's generally copied. So as we talked earlier, that pig also has got a vibrant community. And every day some people would be writing some functions for pig. Every day people would be writing functions for pig, and they make it available to you by the way of this repository. The if you want to use somebody else's repository, you say svn checkout and then you specify the URL and check out the code and use ant to build it, and then once it is done it will create a piggybank.jar, just like the way we created our jar. And then you can start, after registering this piggy bank, you can start calling those functions. All right. For more information about piggy bank, you can look at it. So it's a common repository where all the contributors contribute the various kinds of plugins for piggy. All right. Now there is something called for each nested. So inside for each, what we have so far seen is only a syntax called generate. But at times you will realize that for each gave us a control over each tuple, and inside that, if we want to do more, if each tuple contains so many values, then you might want to do various kinds of things inside for each, right? Exactly for those cases, the for each nested has been created. Okay. So for example, let's take a problem of N- names of the people and cities. We want to find out how many distinct names are in each city. Okay, you have been given that in Bangalore there is Sandeep, again Sandeep, then in Bangalore there is Vivek, and then in New York there is John, and there is again John. So what we want is Bangalore 2 and New York 1. These are the distinct names in each of these cities. If you have to do the same thing, what will you do actually in Pig? Yes? Okay, you will do group. Good. Then you will do for each and then count, right? All right. That's very correct. So the way it happens is this. All right. So we will do it using for each nested. So here what we do is after grouping the data by city, what we are saying for each group, whatever we have inside the group, will will run that via another set of functions. Okay, so for if you remember that when we group things, you have first is the group name, second is the people, second would be, okay, let me show you this. All right. Okay, so wh- if you recollect, yeah, so after grouping, if you notice that we get a bag of values like this. Okay, we get a bag of tuples, right? Now, this list of tuples, when you after grouping, when you do a for each, this list of tuple can be fed to another round of functions, such as distinct and such as, so for them, this will become the input. Okay, this will become the input. All right. So here, when we say for each group, we are given each record. And if we say people, so group will have one variable called group and other will be people. So people is made available inside this curly brackets. Okay. That is why if you see, we are able to call distinct on that bag which was created due to grouping. Okay. Generally generally whenever you are grouping things, whenever you're calling these functions like distinct, you generally call on top of the main data set, not on the part of it. Here, for each entry, we are able to call these functions like distinct. Okay, this will give us the distinct names, and after that, we will generate the output. There has to be one generate as part of for each. Here we say generate group and count d names. Okay, and that will generate things like this. Is it clear? All right. So this is called for each nested because inside the for each, we can have another for each. We could say for each people in for each people generate this. Okay. We could do that as well. All right. So that is what we call as for each nested. Now, the further steps, so far we have talked about only one thing in case of optimization, that was parallel syntax, right? That was parallel. But a lot of times you get various kinds of circumstances in which optimization is required. And one of those circumstances is this one. Take a look at this problem. Imagine you had a huge table of 1 billion entries, and this table is a relation between person name and the country they belong to. All right. And then there is another table which contains country and their code, country code. Now, what we want in the end result is name of the person and the country code. We want to basically convert the country name into country code. Okay, so there are around 100 entries in the country code, while there are 1 billion entries in the citizens table. This is citizens table. Now, if you have to do this, what other things will you do? If you simply join these two tables, join this and this on the country column from both the sides, and then you say generate this comma this, right? That would be the default approach. So, but do you think that there is a challenge in that approach? If you had to do it, could you do it better using MapReduce in some way? So this, the important part here, the thing you need to notice is the second table is very small. It is hardly 100 entries, which means hardly 1 kilobyte. So there is one table containing billion entries, other table containing only 100 entries, which is hardly 1 kilobyte. Do you suggest an alternative approach? One is joining them in a regular fashion. There could be other approaches that could lead a better output even without a reducer. Okay, so Anand is thinking in terms of combining both tables. Okay, so that approach will require a reducer. That approach will have other kind of that approach will require a lot of sorting. But do you really think that you need to sort this data? Yes, we can do that, let's say. So yes, Johnny, let's assume that we are able to split the volumes into datasets. Mhm. Yes, you can take a sample, definitely. Okay. Johnny says that first break the thing into small parts and then make it make do whatever you want to do on smaller parts, and then once you're done you can join it back. Yes, that's probably the approach which you would do before coming to Hadoop, because Hadoop is exactly doing that thing for you. Hadoop is exactly dividing the data for you. So again, here there are 1 billion entries in one table and other containing only 100 entries. So if we load the second table into the memory and prepare a hash table, and as we are going through each record, one record at a time, in this table, we keep on replacing the countries with their country code. Okay, sounds good to you? No? So that will not require any reducer. So this is what is done by fragmented join. Fragmented join or replicated join does exactly same thing. When it says replicated, it means that it will take this table, replicate it all on the nodes on this cluster, and then wherever the mapping is happening, whenever we are doing a projection, then it will just look up in this table, in this country code table, where just to look up for country to convert it into an country code. Okay, so in these circumstances, in these kind of exact circumstances, okay, we use replicated. All right, so you understand when to use replicated. All right, great. Now, all right, now there would be other circumstances. When you are grouping by some column, you realize that for one particular value, for one particular key, there are so many values which are coming together, and for other keys, there are only few values together. Okay, so for example, all the users in a city, for one city, it could be hundreds of thousands. For some islands, it will be maybe 100. Okay, so whenever you are doing grouping and you realize that the data, the number of keys might be heavily skewed, meaning for one key there are so many values, and for some keys there are only few values. In those cases, joining will result a lot of problems. Okay, if you are joining on a key where the values will be too many for few keys and too many for others, then using the skewed command will make a lot of sense. Okay, So in this table, users table, the the key called city might have lots of values or might have too few values. In both the cases, we use the keyword called skewed. All right. Okay. Now, there could be cases where the data you are joining is already sorted on the key which you are joining on. Okay. If you have data which is already sorted on the same key on which you are joining now, so which means that the data does not need to be sorted, and you want to explicitly tell pig, you tell pig, hey, I know my data, my some of my data is already sorted, don't touch it. You don't have to resort it. Okay. So in those cases you use the keyword called merge. Okay. Now you might argue that sorting the sorted data will take a small time. Do you think do you think sorting the sorted data is very quick? If sorting for the first time takes 10 seconds, sorting for the second time, sorting the sorted data for second time will take only few milliseconds. Do you think it is that way? All right. So generally it takes the same time. But in case some of the algorithms in general, the binary search tree, if it is not done properly, it actually takes horrible amount of time to sort the sorted data. Okay? To sort the sorted data, it takes horrible amount of time. Okay? So basically, sorting the sorted data does not add any benefit. It will take the same amount of time. Because the data volume remains same and the algorithm doesn't know what it's doing. Okay? All right. Therefore, exploiting the data property that it's already sorted will give you a very big win with respect to performance. All right. Now, another case scenario is mostly that you group by the same column after joining on the same column. Okay. So while joining itself, you can say, I want to group these table as well as join these two tables based on the same column. Okay. So for example, we have owners and pets. Adam owns cat, Adam owns dog and pets, the name of each pet and the animal which one it is. And we want to bring all these things together for a cat. Something of this sort. Okay, we want to say cat is owned by Alice and Adam, and is a whisker, are with a name called whiskers and paws. Okay, so we want to bring all this data together after joining them. So if you are joining by the same column and grouping by the same column after joining, then you might like to use co-group uh, for that use those kind of use cases. All right. So this is clear. The co-group is clear. The skewed data is clear to you, and merging the sorted data. So these are all optimization keywords provided by Pig. Okay. And these are the reasons why Pig was created. This is the reason why Pig was created in first place. So co-group is used when you are joining two tables and you want to group these two tables just after joining on the same column on which you just did, on which you just joined them. So if you use co-group, your overall performance will be really, really better. Why? Because while joining, it anyway sorted the data by animal here. And after joining, when you do group by, the again it will try to sort it. Okay. So in those scenarios, you basically first group both the sections and then join it. And you could also say while joining that my data is already sorted. Okay. So so that it does not happen, it does not do the sorting again. All right, so either you use co-group or you say that my data is already sorted and just use merged. All right, good. Now at times you have things like union. Okay, where you want to take one data set and you want to take another data set and put them one top of another. Okay, in all those cases where you're just trying to combine two data sets together, you want to use union. Okay, union will basically join the two data sets together. Okay, it will not care about any columns or anything. It will just put one data set just below another data set. For example, I will show you. We have here, we have a, so we'll have something called a and b. If you have a look at a and you have a look at b, okay, we say C equals to join A comma B, not join union A comma B. Okay, we say, can you see my screen? So what will C have? Anybody? A has A1, A11, A12, A21, A22, while B has A11, B12, and B21 and B22. When we say union, it will put these records just above this one. You can see if I say dump C, you will see these records one top of another. Okay, it's just like saying cat file 1 and then file 2, where it will just concatenate these two files. What did it do? Why did it happen that way? Cat A, cat B, C equals to union A and B. Union A, comma B. Oh, we were using capital C there. Dump C. What did we do actually? Yeah, we did the right thing. We did the right thing. Still, it gave a wrong result. Mm-hmm. It's reading some other file. So we have cat A. Oh, we have to load first. You are right. We need to first load A. B equals. Yeah, it was dumped because we did not load. We just started using whatever we were doing earlier. You got the problem? All right. So it will basically give results from A and B combined together, head to tail. All right. Now there could be a case where you do these kind of things. Now you can see that there are 4 rows and 2 columns. Okay. Now say you have loaded A as x comma y. It has got 2 columns, and B as z comma x. Now what you want is you want to union it on schema, which means the schemas of 2 tables will be merged properly. Okay, so all the records, all the column values of x will come below x, while all the column values of y will go below y, and so on. Effectively, there will be 3 columns, x comma y comma z. The records from A will occupy x and y, while z column will be free, and records from B will occupy z and x, while the y column will be free. Okay, now you can see if I say d equals, okay, and say dump d. All right. How do we sort data on union output? Okay, now you can see this clearly. You see between here the column is empty, and here the column is empty. You can see that the column is empty there. Here also column is empty. And similarly, if you say describe D, it will show you 3 columns, while describe A is this and describe B is this. Okay, A has got x and y, B has got z and x, and D has got x, y, and z. All right. Sounds good to you? The union on schema is clear to you? No, I have not answered your question yet. How do we sort data on union output and group or count? Yeah, so what you do is you assign the data like this, you join the data after unioning, and then you can basically group in the same way. You can say group D by say X or whatever you want to do. You can do all of that. Okay, just like this. Okay, sounds reasonable to you? All right. Now that is union on schema. So again, a little bit teaser. What will be the result of join A comma B? So what will be the result of join A comma B? Anybody else? Mm-hmm. Okay. Okay. It's a little bit of a teaser. That's a hint. It's a teaser. It's not really a problem. More like a brain teaser. So we have already talked about it. What happens when, in case of join, we don't specify the key on which we have to join? What happens? Yes, join requires some column, otherwise it gives an error. Perfect. Okay. So since this was in case of SQL, if you join two tables without providing any value, if we join two tables without providing any columns, it will basically do a cross product. It will take all the rows from A, and for each row of A, it will combine it with all the rows from B and generate new set of data sets. Okay. In case of SQL, that was the case. But in case of pig, if you do want to do the same thing, if you really want to do the same thing, you have to use things like cross product. Okay. You have to do things like cross product. You have to say cross daily divs. Okay. If we say cross A comma B, and we say C equals cross A comma B, and we say dump C, then what happens is, okay, so let me again talk about it. Let's say there was one table called A containing A1, A2, or let me take a practical example. Let's say A contained adjectives. There is a table called adjectives. Okay. it basically contained things like good, bad. Okay. And there was another table called nouns. Okay. We say girl, boy. Okay. And what we want is we want to generate all combinations such as good girl, good boy, bad girl, and bad boy. Okay, that's what we want to generate. And if there are, say, thousands of adjectives and thousands of nouns, then it will be very difficult to do it manually. Okay, so this is what we call it as cross product. Okay, you can see that each record from A was taken and generated against both records of B. Similarly, second record generated combined with both the records one at a time. Okay, this is cross product. So is it already combining A? No. So in case of A, if you see A is this and B is this. So it took this combined with both one this and one this, and therefore we got two rows. And then we took the second one, combined it with this, combined it with this, and we got these two rows. Perfect. All right. So this is called cross product. All right. In the real practical life, there will be few more challenges you might face, such as how do I. So what do you do in the real life? Once you have created your report, you want this report to run every day, and this report might take the parameters of today's date. It might take parameters of today's date, and so on. Okay, and so that while you are executing this report, you don't have to change this report in order to run it. It is possible to pass the arguments to pig while executing a report. So how do you execute a report? You say pig and pig script. It will run all that script. Now, in case this script has got a variable which you can basically specify the value of that variable in argument. So imagine daily.pig is your script. In the daily.pig, you will see yesterday equals filter daily by date, and you specify a date. Okay, you specify things like dollar. And how do you substitute it? When you're running this script using pig command line, you can pass this in the argument. Okay. All right. In case you have got many arguments and you want to pass those arguments, you can create a params file and keep it there. And then while running the script, you can specify that my params file exists in this. My params file is this, so that all the variables found in params file will replace the daily.pig. All right. Any questions still here? So if you have to break a data set into multiple data sets, there could be multiple ways that you could do. For example, in this, if you want to split it into multiple data sets, you could say w1 w1 equals equals filter w logs by timestamp. Okay, we could say things like this, and we could basically also say things like this. This. Okay, so that is one way of doing it. But if you see this, it might be too much of time consuming for Pig to do it this way. Why not, while loading data itself in the single map, if you could do, it could do all these things in a single shot, it could have been far more efficient. And that's where the split command comes into play. So instead of having multiple filters, you can write inside split command itself that split my file into this portion, and this portion based on these criterias. All right. So a single record can go whenever we are splitting a data, we specify in this format, split my data set into something if timestamp is lesser than this, something else if timestamp is between some other values, and something else like this. Okay, so these statements are not very mutually exclusive. Although they exist under the same umbrella, it does not mean that a record which went to April 02 would not go to April 01. Okay, and it's not also mandatory that if a record could not fit in April 03 or 2, it has to necessarily fit here. Okay, there is no such constraint. So a record can be dropped out completely, or a record could be multiplied also. Same record might go into any of these legs. All right, so that is Pig's splits. Now, Pig does a lot of optimizations when you are executing your queries. Okay, first is parallelization of the work. The execution of the work is not really linear. Just like in our programs, we write the programs in top-down approach. We start from top. The processor will start from the top, will go till the bottom, right? In our programs, all so far has been linear execution. Okay, but here in case of Pig, the execution is not linear. Only those things are executed which depend on certain other tasks. Only those things will be executed which are in the path of dependency. So let me describe it with a good example. Let us say that we had A equals to load something, B equals to filter A, and then something, C equals to group by A based on something. Now if we say dump C, what all will get executed? Can somebody tell me? With respect to line number, this is line number 1, 2, 3. So if we say dump C, what all will get executed? Anyone? Only A and C, right? Thank you, Rajesh. So Johnny, not all three will get executed. This will just be noted by Pig, and whenever required, when we say dump D, dump, let's say there was dump D equals to order B by something, right? When we say dump D only, what will happen? Had it been dump D, what all will get executed? Yes? So A and D, because when we say dump D, it will depends on B and B depends on A. So first, second, and third is what will get executed. Perfect? Great. Makes sense to you? Anand, did you get it? Good. Any questions here? All right. So this is what is called non-linear execution. Also, it tries to combine multiple things into a single map. As you can see in this border, multiple things are being done inside the single map. Okay. It tries to do a lot of optimizations in order to give you the results. Okay. Now for more documentation on custom load functions or general documentation, visit these references. And if you have any questions, please feel free to drop us an email at Sandeep at No Big Data or reach us. You can write on Hadoop at No Big Data. All right. Any questions here? So that completes our pig sessions. Go through the online test, go through the go through the subjective test on our website. Okay, I'll describe a little bit about the subjective test. All right, here you can see there is a subjective test and there is a basic quiz. Please attend both of them. If you have any question at any point of time, please ask me. Okay, so in this subjective test, okay, in this subjective test, you are given one tweets.csv. Download that, have a look at it. You have to first write a program that gives you, so you are given three tables basically: tweets, users in the form of CSVs. Okay, all you need to do is give me user login and username per state. Okay, for the New York state you have to give all users in New York state. Okay, that is first question. Now second question is, the data remains same. Second question is that find out all the tweets which contains a keyword called favorite. Okay, use regular expressions that will make your life easier. Third is write the MapReduce program that computes the natural join between the two data sets based on user login. Okay. Fourth question is write the same as the previous one, same as third question. Same as third question in the form of using pig Latin instead of MapReduce. Okay. Then number of tweets per user. Go through all these questions. These are very straightforward and simple, and do it in the Perl. Do it basically on the website itself. All right. Go through these tests, subjective tests, and try to finish it. And when you're done, you just submit the answers here. Okay. All right. You just go to my courses. You will see only two courses probably. For me, you will see so many courses. Okay. All right. So if you have any questions, feel free to drop me an email at Hadoop and No Big Data, and that's all. Okay. All right. So let's take a break for 10 minutes. Let's take a break for 15 minutes actually. I have a little more work to do. Hello everyone, can you hear me? I'm back now. Should we start? Great. All right. So now we want to start with something called Hive. Okay. So just like Pig, Hive is also trying to avoid the pain of writing MapReduce code. Okay. Because writing MapReduce code requires a lot of efforts. MapReduce code is even difficult for developers. There will be lot of repeated logic such as joins, and therefore MapReduce code is not great in when it comes to in real-time scenarios. Okay. Second, everything seems to be great. Like Pig was good, and but it will still take a lot of time for a lot of users to adopt Pig. Okay, those new users are picking up the Pig, but those existing users are not really inclined to learn a new technology. All right. Now, there are a lot of SQL users, database designers, and database administrators who are quite comfortable with SQL. So it will be difficult to get them learn Pig or Pig Latin. Okay. Also, there is a lot of SQL queries and a lot of reports written in SQL. It will be very difficult to migrate them into a completely different language, no matter how. So that's where the role of Hive comes into play. Okay, so Hive makes it possible for users to write SQL which can be executed and you get the results. Okay, and these SQLs basically under the hood get converted into MapReduce logic just like our pig. Okay, so the value proposition of Hive is it is very much suitable for data warehouses and good when you have to analyze relatively static data. Also, it is okay when you do not need a fast response. In case you need a fast response, Hive is not your solution because Hive is built on top of MapReduce and MapReduce is a batch process. It takes time uh, at MapReduce to execute a query. The only powerful thing is no matter how big is your data, Hive will be able to churn it. Though there'll be delay, there'll be latency, but it will be able to do. And it makes it easier for porting existing projects where you have already had SQL You can actually start using the same SQL with very minor differences. It Hive provides you SQL dialect called HiveQL, which is very close to the standard, all right, which is very close to Oracle, all right. It Hive maintains a metadata of all the tables you want to load, unlike Pig, where we used to define the metadata in the script itself while loading. When we said load this table and these are my column, this is my data type, we were defining the data type there. But in case of SQL, when we create table, when we create view, we need to create them sort of permanently, and it has to be stored somewhere. Those tables need to be stored somewhere, and that's where the role of metastore comes into play. Okay, so now I mean, after this sentence you will realize that this is probably one of the biggest difference between Pig and Hive. Hive need to have a backend store, which means Hive need to have some sort of service running on the server. Okay, this service is responsible for storing the metadata, and that metadata gets stored in your relational database. Okay, and this metadata is not really stored in HDFS. Instead, all of this metadata is in the SQL. In the Oh, my voice is breaking. Okay, let me just reconnect it. Now, can you hear me? All right. So, in our regular database, when we say create table and we provide the information, it need to store this table information somewhere, right? Similarly, in Hive, when you say create table, the information about the table need to be stored somewhere, right? Okay. Okay, that's correct. Thank you. Let me go over the last 4 points. First is it makes it easier to port existing projects, which means the SQL dialect which is provided by Hive is very closer to existing ones. And every and now and then they keep on trying to make it very portable. Okay. So it makes it possible to port your existing projects onto onto Hive. Okay. Second is it provides the dialect called HiveQL, which is very close to Oracle and is perfect SQL. Last is it maintains metastore for storing the table definition. Okay. So when it is Hive and when Hive is basically a SQL query processor, it need to understand how to create a table and how to specify the column values, and those tables need to exist even after we close the session, unlike Pig, where if we close the session all A and B and C, whatever we created, all those data sets disappear. That's not true in case of Hive. Those data sets or the tables which we will create, they will exist as if in the real database they exist. All right, this information about table, like what are the columns, what's the name of the table, what is the data type of column, this is called metadata. This is called metadata, and this metadata is stored in metastore, which is essentially, in our case, is it is MySQL. Okay, is so this was clear, right? Or was there intermittent problem as Rajesh is telling? Yes, so this metadata is read by Hive. All right. Suppose any change in the structure of table happens, Hive automatically updates the structure of the existing table. Okay. So basically you are thinking that it is just a second. All right. Yeah. So whenever you do an alter table, there is a syntax given by Hive which provides alter table kind of syntax. If you do that, it will update the existing table in the metastore. All right. Yeah, you will have to manually do it. Okay. The way we loaded HDFS file in Pig, we can also load the same file, similar file into our database Hive tables and start using our queries. Okay. There are few limitations of Hive. First, the most important one, which we should not forget, is it does not provide you the syntax like update, insert, or delete. Okay. All you can at most do is whatever is the result, save it in new database table. That's all. You cannot do things like insert into Hive table or update or delete from Hive table. But you can definitely generate new tables. It's not suitable for online transaction processing. Reason being, the queries have higher latency. Hadoop, the MapReduce framework which we are using, is heavily batch oriented, meaning you execute it and forget it. Whenever it's done, it will update the status on the website. There is always an overhead of a startup because it has to convert your SQL query, understand it, parse it, and then generate MapReduce code. So there is a startup overhead, and also whenever you run anything on Hadoop, there is always a delay in its booting up because there is a Java virtual machine which will run and will take some few milliseconds to run. Okay. Hive is great when you have to just mine and maintain a large data set. You already have that data set well maintained, and you want that database to mine. In those cases, you use Hive. All right. So this is the architecture diagram of Hive. Most importantly, at the bottom you will see there is a whole Hadoop components. You have master, you have job tracker, you have name node, you have everything. And in the above, you can see clearly that there is, in the above part, you see that there is more, there is something called driver. That driver basically takes your SQL code, compiles it, optimizes it, and then executes it. Okay. Along with driver, there is metastore. Driver communicates with metastore to figure out what is it you have defined in your tables, as in how many columns are there in this particular table and what are their data types. So all of that is from this metastore. All right. And also you will notice that unlike pig where we could any load any data, here you need to upfront define everything clearly. Okay. And this driver who does all of these jobs, it is either called from command line interface or called from Hive web interface or from thrift server. Okay. So how many of you know what is a thrift server? Okay. So thrift server is a standard service SOA component, service oriented architecture component. Whenever whenever you are building some service and you want that you want to generate a lot of clients for yourself. Okay. You want to generate clients such that people from C background, C++ background, Perl background, Python background, all of them get a library and they all can connect to your service. In those cases, all you do is use things like thrift server, and you just define an interface language, and thrift converts that intermediate definition language into lot of clients, and all these clients can connect to your thrift server and communicate with you. Okay. So whenever you are building a service, you will see this pattern everywhere. You will Whenever you are building service, you generally utilize thrift. Same case is true for HBase. Same case is true for other services. All right. Now, people from Java background can also talk to thrift server. From people from ODBC background can also talk to thrift server, and all that whole stack stand on top of thrift server. All right. Now, the secondary clients are things like Karma Sphere, Hue, Qbol, and lot many kind of user interfaces are there. All right. So this architecture is clear to you. You either interact with Hue or you directly use CLI, but you will be always using this driver, and driver will be utilizing Metastore and talking to Hadoop. Make sense? No? So thrift server is basically a service where you implement only one side of the layer, and it generates all kinds of clients from that. All right. So I think it's only clear to Johnny. And any doubts about thrift server? All right, great. Moving on. Now, the word count example will look like this. You first of all copy the file, which is okay, everybody knows this. And then next is you run this query in Hive. This is how your Hive will look like. It's a standard SQL where you say that take this particular file, okay? First create a table. There will be a table, okay? There will be first you have to create a table called docs with one column, and after you have done that, load this data into this table. After that, first thing you do is you break it by spaces, and after breaking it, you generate one word per line and count as one. And after that, you basically group it by, okay? Okay, you group by word, order by word, and there we go. Once it is done, you can do the word count select star. Okay, so this is how it would look like. Okay, I know it won't be clear in a single shot, but it's good to know where we what are we getting into. Okay, there are multiple ways to get started with Hive. The easiest one is you just connect to a server and then it gets started. Or you can install any virtual machine either from Hortonworks or Cloudera. You will see Hive installed in them. Okay. Once, but you don't have to worry about all of that. You just have to connect to our servers and that's all. Okay. Once you're done with it, you can either execute Hive from command line like this, or you could execute Hive with a single query. If you have just one query, you can utilize this kind of command line argument. Okay. If you have just one query you want to execute, you can do that. If you have bunch of queries which you run every now and then you can say hive minus f and this particular file. Okay. You can provide the location of your SQL file and it will run it. Okay. And this is how it will actually look like. You can give it a try quickly and let me show you. So I'm already logged in. I say Hive, so it's coming up. Is the font good for you, or do I need to increase the font? So I say create table X, select star from X, and then drop table X. It's as simple as that. All right. Now, so no, you'll have to create your database. Santana's question is that is it specific to user, meaning will the tables created by will be my username? So in general, yes, but in our installation, all the tables are created in student and we have shared the same login with all the users. So you will have to create your own database before you start doing anything. Okay. And Hive also provides security such as your table cannot be accessed by other people. All right. Now this Hive prompt, let's get to know a little bit more about. You can execute any any Hadoop commands. Okay. You can execute any Hadoop commands. So you can first is DFS commands, Hadoop DFS commands, where you can say things like copy from local and all of that. You can say copy from local. Okay, here it's saying that you need to provide these arguments. Okay, so basically you can run DFS commands, Hadoop's DFS commands, and you can also load an existing query language, existing script into your prompt. So all you need to do is source path to whatever you want to call it, source my dot hql. Okay, so this way you can load a file. Here there is no such file, that's why we are getting that error. All right. The comments in Hive start with double dashes. To set an environment variable, you can use set year equals to something. Similarly, you can utilize that variable you are creating like this. You can refer to the environment variable. And in case you want to execute local command, you can simply say exclamation and ls. This is being executed on local machine. Rather than you coming out of this console and execute the command, you can do that from inside of the command prompt itself. Okay. Now the basic data types are very similar, and the tendency of Hadoop is to combine the data types from all the SQL syntaxes. Okay, say for example, binary and Boolean both have been included because different database have different name for the same data type, right? Hive's problem is that Hive tend to absorb all of these idiosyncrasies of these programming languages so that every query is compatible with Hive. All right. So for example, you can see there is varchar, there is string, and there is character. Similarly, timestamp and date there can be used interchangeably. All right. So the overall objective, why there are so many data types, you can see that in version after 0.12, this was introduced. After 0.13, this was introduced. All right. So these are simple data type. These are very simple data type, but you can define very complex data types as well. For example, array. Array is essentially a list of things which are indexed by numerics. Second is you can also define a data type called map. Map contains a key value pair, a collection of key value pair, where key is the primitive data type and value is any data type. It could be complex, it could be primitive. And then struct is something very different. So out of all the values we define inside structs, only one value can be accepted at a time. Okay, only one value can be accepted at a time. That is struct. Sorry, I'm extremely sorry. So what I described just now about struct is actually about union. Struct is standard class, just like your C, where you have a bunch of key value pairs, just that keys are predefined strings. Okay, so you have arrays which are basically just like your C arrays. Maps is a big hash map of key and values where key is a primary, basically primitive data type. It can be numeric, it can be string, it can be character, while value can be any data type. Value could be the array. Okay. Struct is like your C programming language struct, where you define that this is my struct where there is a name, there is age, there is last name, there is email ID as the field keys, predefined keys. These are fixed predefined keys. You just have to fit in the values. Okay. So that is struct. Union is a little bit different. Whenever you define union, you say that in this place, a union is based on these three data types. At one time, only one of these data, one of these types will be present in this column. This is useful. For example, you are maintaining the authentication label. You are maintaining a website where users are logging in using various kinds of mechanisms. Some of them are using Google Plus, some of them are using Facebook login, and some of them are actually registering on your website. Now, in the users table, you will have to mention what is the user ID. Okay, so for Facebook it will be numeric, while for Google it will be a email ID and so on. Okay, but they will all take a single column space. So that is called a union. Okay, the way you define is very clear from this table. You can define normal primitive type like this, which is exactly like databases. We say the name of your field and then you say the type of the field. Then you define subordinates as an array of strings. Then you define deductions. Deductions is a map between string and the number. Afterwards, you define the address. Address is a struct, as address is the struct containing the name of the street, city, state, and then you define something called authentication. Authentication means how is the user authorized. Okay, whether it was Facebook ID, Google ID, or email ID. Facebook ID could be string, email ID could be string, while Google ID may be integer or long. All right. All right, so let me define union once more. So union, can you see here? I defined a field called auth, and it's a union. In the definition of union, you can see Facebook ID, Google ID, and email ID, right? Now at a time, you will have only one of these data types present instead of all these three. All right. In such cases, we define the union type. when you when you only want to occupy one of these kind of data types. Make sense now? So for example, authentication can be either through Facebook. Person came and clicked that I want to authenticate using Facebook, or it can be either, but all these three cannot come together. All right, that is union. Yeah, no combinations, only one of these three values. All right, now just like a standard database, it provides a level of abstraction called databases in which you can keep your work separate. All right. So now it'll be clear to Santana that this is how you should be doing. So before you start working, create your own database, create database, your database name, and then it will show you the list of databases. Okay. Inside the database, you keep on creating your table. And in case you don't select a database, then in case you don't select a database, then by default, there is a database called default in which everything will be done. Okay, so Rajesh's question is, when we have something like union where we use one of the data types, aren't we wasting space with not using other types for a set of records? So Rajesh, let me explain to Rajesh that that is exactly the purpose of a union. Unlike a struct, in struct, in case you are setting a variable, it takes up the whole space for the object. While in case of union is the same memory which is allocated for all these data types. And only one memory is occupied by one of the data type at a time. Therefore, it does that exact optimization which you are looking for in the union. Okay. So only one of the values will come at a time. Therefore, there will be only one allocation. Exactly. Continuing with databases, database is the basic level of abstraction where for each project you generally tend to create a separate database, and inside the database you can start creating your tables and continue the work. All right. Also, if you want to display the current database in the command prompt, you can use something like this. Now, if you see right now, I am in default database. I can say use asgiri. Now I'm in asgiri database. Inside this, I can see all the tables, right? Also, I can see show databases and it'll have all the big list. Okay. So this is how you can create databases. Before you start working, create your own database and we will you will keep all your tables in the database. Do not forget to use your database while you connect. All right. Now, similar to SQL tables, we have tables here. We can say show table, select star from my table, describe my table, describe formatted my table. So show tables list all the tables, select star from my table lists all the rows and columns of my table, while describe my table just gives me the little bit details about my table. In case I want more digging, more information about my table, I can say describe formatted my table. Okay. All right. The concept of in case of Hive, there are basically two kinds of tables. One is managed tables and other is external tables. The very basic difference between the two is The managed table is created on top of your data, while external table is created on top of the data which is external to you. In case you drop managed table, the data will disappear. While in case you drop an external table, the table which is external, meaning the data of which is not under your control, in case you drop an external table, the data doesn't get deleted. It's kind of like federated table. That was Anand's point. Yes. All right. Now there is something called Hive Meta Store, which basically stores the metadata of the table into the database. Okay. Now metadata can include what are the databases available, which tables are there in those databases. All of this information is metadata and is stored inside MetaStore. Okay. So this is how you create a managed table. Let's create a managed table. So here I am. Now let me just create a database for Fab 28 and use Fab 28, right? Now let me see show tables. There is nothing right now, and we just created one table called NYSE. Okay, we can say show tables. Okay, and if you want to see what is there inside this table, it is NYSE daily. Okay, now you will be surprised that how come the data already exists, because this path, the data is already existing. Okay, in case you drop the drop the table and try to create the data table again, then it will disappear. Okay, you can drop the table, drop table. So when you're dropping the table, the actual data is going to going to disappear. And now you can say select star from NYSE daily. Okay, so now it doesn't have any data. So what we did was we basically created NYSE daily inside our database, but this location was already existing. This location was already existing. So when we said NYSE select star from NYSE daily, we got the data. But after that, we deleted this table. Because this is managed table, it deleted the data folder also. Okay, makes sense to you? Managed table, whenever you drop them, they delete the data. All right. Now that is a managed table. And to load data into managed tables, yes, you have to be careful while handling the managed tables. No, we did not do that. Okay. So let me just load the data into our table which we just created and is empty. Like select star from NYSE daily. Okay. We say load data here. If you look at it, it says load data local in path in this folder and overwrite into table called nysc daily. Now after that, this is in path. When we say in path, it means when we say local, it means my local folder, not from HDFS. If we don't specify this keyword called local, it will try to find this file in the HDFS. We'll try to find this file in the HDFS. And when we say overwrite, meaning old data in NYSE daily will get overwritten by this one. Okay. Okay. So this is the way it is done. Also, please note that when we say load data from local file, the data is copied to HDFS. In case we are loading data from HDFS, the data is actually moved instead of being copied, because the data is already so big that it does not, if it creates another copy, it will be too much of disk space wastage. Okay, now that is how you load the data from local folder. In case you want to load the data from HDFS, you can try this. You can say Hadoop fs copy from your local folder, you copy there. After that, so let's just copy it. So yeah, you have to go to the command prompt, copy this. Yeah, that's correct. That is correct. In case you are deleting a managed table, it will definitely delete from HDFS. Okay. Now what we are trying to do here is we are trying to show you, in case the file is existing in the, let me connect to SSH, not this one, SSH student. Okay, now let's first take a file and put it into my folder. All right, now it has been copied into SKD. Now in case you can see that if it is copied or not. Right, so it is copied from my local folder to HDFS. Now next step is, in the same table we are trying to execute this. Okay, it says load data in path this, overwrite this table. Basically it is trying to load the data from HDFS, and in this case, whenever you are loading data from HDFS, whether managed table or unmanaged table, either case the data gets moved. Now if you try to see this, it says no file or directory, right? So the data got moved rather than data getting copied. Okay, so whenever you are trying to load from HDFS, this is what happened. Okay, by default, so whenever we say load, also please pay attention here. Here we say create table, we define all the columns, and after that we say row format is delimited fields by tab. Okay, meaning that NYSE daily, when we are going to load this, it is going to consider the data as tab separated and then load it. Okay. So with the moment we say load data, it basically finds out where is the exact folder, copies it, and once that is done and you say select star from NYSE daily, it will try to load the data from the file which you have just loaded. Okay, so that is how the loading is done. Next is, once you have this table ready, let's say our table is ready, select star from NYSE daily. So this table is ready. In case we had not provided here in the previous screen that our data is separated by tab, it will be trying to load the data based on control A. Okay. Now once you are done with this, you can do any kind of beautiful query you want. Okay. So like for example, I'm trying to load the data for symbol CMC. Once once you have something structured in SQL, when you have something structured, it's fairly easy to do the queries. The only thing is preparing this kind of data, it takes a effort. All right. Any questions here? Great. Now, all right. Now, so first we created this table. We told that our data is going to be here, right? And then we loaded the data, and you can actually check where is the data. You can say Hadoop fs minus ls, or you can go to the hue and check it, and you can say slash data. Now you see this is the file containing the data. This is on HDFS. So whatever location you provide in that, it does store there. In case you have not provided the location, then it basically tries to store in the this folder. Okay, apps, hive, warehouse, and all of that on HDFS. I'll show you. So Hadoop, I'll say 888. So you go to the file browser. Okay, you can see that for each database we created, for example, 21st Feb we created, yeah, or we, yeah, I think we created 21st Feb. So for each database you create, it creates a folder. Under that, you have these name of the tables, whatever you have created under the table says, and so on. So is that clear, Rajesh? Now, the question is, where is the metadata? This is the actual data, okay? This is the actual data, and but in our case, the actual data is also not in there. Our actual data is in this folder, okay? In this folder, whatever we had defined here in this folder, okay? I'll show you. If you go here and you edit this location and you type this, you can see that in this folder there is a file containing the data, right? Now, the meta store, you can quickly see where did my meta store go by saying MySQL. I'm logging into MySQL database, and you can see that here under this so basically I'm trying to show you where exactly it's storing the metadata. Okay, so when you say store databases, it shows you that use Hive, and here if you see under this there are many tables. Hive is storing your metadata information using so many tables. Okay, out of this is probably the most important one. Under tables, you can see every table whatever we create is created here. So NYSE daily which we just created has been created in this file. Okay, so this is the meta store for us. Okay, is that clear now? Good. So it will generally install by itself. If you are using Ambari, it'll install by itself. You don't have to worry about anything. In case it does not, then you will have to install it by yourself. All right. So that was about loading the data. In case you want to take the table and save it into HDFS or elsewhere, you can do things like insert overwrite local directory and select star from whatever query you want to write, you can write here. Okay. In case you want to store your results in HDFS, what you can do is instead of using local directory, you can say directory directly. Do you have instruction in install? Oh, so that I have not provided, but it is fairly straightforward. So the general instruction is in Ambari. Yeah. So first one is install Ambari server on the main one. Then you install Ambari agents, and then you go back to the Ambari server and say add host, and then you start adding the host on which agents are running. Okay, so you add hosts on which agents are installed. After that, you tell Ambari server to install various services on the agent, and that way you can install anything you want. You can have a look at our here, not this one but this one. Okay, inside Ambari you can say add host this, add host that. Okay, so here you can see that there is something called add service, or there is something called, if you go into hosts, there is something called add new host, where you can type your host names and then register and confirm. That's all. Provide, either you have to provide your SSH key, or you can provide the login password, or you can by default by manually install agent and then run it. Okay, it's very straightforward. Okay, so this is how you can save your data into file system or into HDFS. All right, in case of Hive, there there's something called partitions. Each table has got, each table might be very huge, and we might need to create indexes. Instead of indexes, Hive provides something called partitions. Okay, so if your table is humongous, it does not make sense to keep on scanning the data to reach a point. Instead, if we have created partition, we can just pick up the partition which we want to pick up. Hive will do it for us. Okay, and we can define the partition by clause while creating the table itself. Okay, and we can create partition based on multiple tables also. So this time, what all did you miss? Yes. All right, so there's something called partitions. I'll show you the code and then you will understand it better. So imagine that you had a file, the employee. Okay, this one contains this data. Okay, I'll show you. So all of the data related to Hive is located in Asgiri Hive in my folder. So we can say asgiri/hive, and in this you have cat the employee and cat the employee 1, right? There is not much of a difference. It has, the first one has only 2 rows and with these values, while second one has these rows. You can see that. Now if we want to load it as a single table, first of all you need to do is go to Hive and we say, okay, so we have said create table called employees which has name. Let's go back to the table. Name is n, name, a salary, and degree. Okay, and then there is something extra here, which is called partition by a qualification. All right, here you say partition by a qualification. So this is sort of a pseudo column. Okay, now we have created this table with a partition on qualification. Okay, qualification is not part of the main columns. Now, before we do anything, let's see what's there. It shows you the details about your employees table. Okay, it shows you that there are these three columns. There is a fourth column called qualification, and it also shows you that this table is managed, and the location of the data where it is going to store is this one. Okay, all right. The need for partition table is, imagine that you have got, there are no indexes in Hive. There are no indexes in Hive. So when you have to load data and you want to just look for a portion of the data, then instead of scanning through the whole database, you can just look at a small window, and that is what is called partition. So one table can be spread across 50 HDFS files. Okay, each file is based on a certain parameter. Like here we are defined something called a qualification as a parameter. All right, now we will create two partitions. One partition for qualification equals 1, other partition for qualification equals to 2. So we are loading the data. Okay, one will be the amp and other will be the amp 1. Okay, now we have to provide the location of this file. All right, so before doing that, we will go to our folder, which is cd as Giri, cd as Giri, and Hive. And then we launch Hive and say fab28. Use fab28. Now you can see that I loaded this table as qualification equals to 1. I loaded this file. These are both HDFS files. I loaded that as qualification equals to 2. Now you can simply say select star from employees. Now you can see here, although our files had only these columns, three columns, but this whole database contains four columns, right? The fourth one is on which we have created the partition. Now you will understand what's the utility. In case I say that select star from employees where qualification equals to 2, right? So it will not read the first table, it will only read the second table. Yeah, that's what I mean to say. Whenever I say select star from employees where qualification equals to 2, it will only read the second file. Okay, it will not read the first file. Now it is reading the first file. Okay, also you should have a look at it, where exactly is data going. Okay, where exactly is data going? It is going into this folder. Now if you look at the folder where the table was created, under this there are two files, first one and second one. Okay, there are two files. First one is for qualification equals to 1, and second one is for qualification equals to 2. All right, there could be 100 files, and whenever you are loading one, whenever you're querying it, it will figure out which file are you talking about, and then accordingly it will only read that portion of the file. Hmm. All right. So I did not get your question. Though it's a single table, it is creating records like part 0, part 1. Yeah. So it's based on partitions. Whatever partition are you creating on the same name, the name contains the criteria on which the partition is being created. All right, great. Also, you can have a look at the partition at any moment of time by saying show partitions of employees. All right, good. Sounds good to you? Any questions, or should we call it a day? All right, then see you next weekend. And if you have any questions, feel free to contact and send us an email at hadoop@nobigdata. All right. Thank you very much.